Here is an example going over particle displacement when you're given the velocity of the particle. Now for this example, it says a particle moves along a line so that its velocity at time t is given by v of t equals t squared minus t minus 6, which is measured in minutes per second. Now for the first part, it says to find the displacement, or another way, the net displacement during the time period from t being between 1 and 4, so between 1 and 4 seconds, and then you're to find the total distance traveled during this time period. Now the displacement would be, okay, from first second to the 4th second, what is the total distance between those two positions? But the particle may have moved up and then down or something like that, or since it's going along a line like forward and then backwards, or backwards and forwards, so that it may have actually total distance may have been more. But when we're talking about just the displacement, we're just saying, okay, from the position of the first, or sorry, we would actually say from the 4th second minus the position of the 1st second. So for this one, for part A, you would just do, let's see, bring the pen. So we just say that the displacement would be the s of 4 minus s of 1, which if we're given the velocity function, this would just be the integral from 1 to 4 of the t squared minus t minus 6 dt. So finding the antiderivative of this, so that would be, let's see, so the antiderivative of t squared would be 1/3 t cubed. The antiderivative of minus t, that would be minus 1/2 t squared. And then for the minus 6, that would be minus 6t. Integrating that from 1 to 4. So plugging in the 4, that would be 1/3 times 4 cubed minus 1/2 times 4 squared minus 6 times 4. And then all of that minus plugging in our lower limit. So that would be 1/3 times 1 cubed minus 1/2 times 1 squared minus 6 times 1. So let's see, 4 cubed, that would be what, 64, so that's 64 over 3 minus, let's see, 4 squared, that would be what, 16 times 1/2, so that would be minus 8, then minus 24, all of that minus, see, so that would be 1 cube, or 1 over 3, and then minus 1/2, minus 6. So let's just see, so it'd be 64 over 3 minus 1/3, so that'll be 63 over 3, which would be 21? So that'll be 21, and then minus 8 minus 64, and then minus a negative 6, so that would be negative 26. Then be minus a minus 1/2, so plus 1/2. So that'll be what, negative 5 plus 1/2. So that'll be negative 10 over 2 plus 1 over 2. So that'll be negative 9/2. So this means from the time period from the 1st second to the 4th second, it's gone back negative 9.5 units. But like I said, like let's say if this is on the line that it's traveling, it could have gone, let's say after 1 second, it could have gone like so much that way and then back, or it could have just gone back. So that's what we're saying by the displacement. All we care about is from where it ends minus from where it started. But when we're talking about the total distance, we want to figure out, okay, what is maybe like this distance plus that distance going back, to see what is the total distance that it actually did travel. So to do that, that would be the integral from 1 to 4 of the absolute value of the velocity function. Now what you would do is you would find, when does the velocity function cross the, in this case would be the t-axis because our variable is t. So we set the function, the velocity function equal to 0. And let's see, this one's factorable, so that'd be what, t minus 3 times t plus 2. So that'd be at t being negative 3, or sorry, positive 3, and t equal to negative 2. So since we're worried about t being between 1 and 4, that means it crosses at 3, so it goes from 1 to 3. It's either always positive or always negative, and then it switches from 3 to 4. So now one thing, since this is a parabola and it opens upwards for the velocity function, that means this would be at our 3 and that would be at the negative 2. So we know it's negative between 1 and 3 and positive from 3 to 4. So what we would do is break this up. So this would be the integral from 1 to 3. Now since we know it's negative, but we want the absolute value, one way you could do it is, so that would be the integral of the negative of the function, the t squared minus t minus 6 dt, plus the integral from 3 to 4 of the t squared minus t minus 6 dt. You could have also not worried about the negative and just took the absolute value of the answer at the end, because that way you would have took the absolute value of this integral plus the absolute value of this one, so that when you add them together, you're adding two non-negative values. But anyway, so let's see. So this would be, for this first integral, the negative 1/3 t cubed minus, or now be plus 1/2 t squared plus 6t evaluated from 1 to 3, plus now the 1/3 t cubed minus 1/2 t squared minus 6t, evaluate that from 3 to 4. So plugging in our upper limit, so this will be negative 1/3 times 3 cubed, so that would be 27, plus 1/2 times 9, plus 6 times 3, so that would be 18. And then that, minus plugging in our lower limit, so that would be negative 1/3, plus 1/2, plus 6. And then all of that, plus plugging in our upper limit here, you'd have, what, 64 over 3, minus, let's see, 4 squared, so 16 times 1/2, so minus 8, minus 24, minus plugging in our lower limit, so that was 1/3 times 27, minus 1/2 times 9, minus 18, and just to save time, so when you do all of this, you would get 61 over 6, which is equal to approximately, that it would travel 10.17 meters. So that's how the total amount, because again, for this one, at the first, when it first starts out, let's say from 1 second until 3 seconds, that the velocity is negative, which means it's going backwards, and then it's going forwards. So it's actually, in this case, it's like going, let's say it went like this, and then it went like this. But since it went back more than it went forward, that we know that the displacement would be negative, but the total distance traveled is that it traveled, when you add up those two distances, is about 10.17 meters.